I'm Charles, and I'm on a mission to find what's inside everything. To help me get my answers, I have an industrial CT scanner. It takes a whole bunch of X-ray images from all around a subject, and then builds a 3D model revealing every internal detail. What's inside of a Furby? Well, we're going to scan not just one, but one of every model ever made to find out. So let's take a look inside of these cute, creepy, fuzzy owl hamster things and see what makes them tick. How did we get here? Well, a friend of mine, Matthias, is an avid collector of many things, and that includes Furbies. And when he heard that we were CT scanning anything that wasn't nailed down, he very kindly lent us his entire collection of Furbies. And this is the entire collection of Furbies. We have an Era 1 Generation 1 from 1998, and the most modern 2024 model. To put this in perspective, that's the same range of toy development as the Nintendo 64 to the PlayStation 5. What I want to try and find out is how these things worked in the first place, and how has that changed in 25 years of development? So let's take a look inside. You ever get that feeling that you're being watched?
I'm watching you, Wazowski.
I have 9 Furbies in this room and run all of them through the scanner. We have everything from the 1999 model to the 2024 model. So let's take a look inside and see how they compare across a couple different axes. I want to see what they're using for communication between devices. I want to see how they're listening to you. I want to see what sensors they have on board. I want to see how they move, how the electronics are assembled, and finally, how they make sounds. Welcome to the Furby Scanathon. Let's do this. This is the 1998 model. This is the first generation, first era. Astounding condition for a piece of 27-year-old consumer electronics. Now, I don't have batteries in any of these, because otherwise this whole room would just be full of noises and distractions and bad audio at the moment. Now, as always, if you want to follow along on your own, you can check out the links in the description below to pull up these exact scans in LumaField Voyager. I'm going to have each one of the scans linked in the description below with a tag telling you, which one it is, because it is not going to be easy to tell. So let's take a look. So what's our first challenge here? We want to know how the first gen Furbies talked. Now, I'm pretty sure the answer is infrared communication. And actually, that's why they have this sort of third eye thing in the middle of their head. That's an infrared communications port. So there's a transmitter and a receiver. And as I understand, they actually added this infrared thing, needed a spot to put it in there, and gave them that third forehead eye thing. Never really justified it beyond that in the description of the characters. And now that they've ditched that in later years, they just kind of kept the hole in the head. No idea why. So let's go digging and see what we can find in here. Peel back the fur. Oh, geez. Oh, okay. Look at that. So up here in the forehead patch, we actually have 3 devices. I thought we'd only find the 2. We have these 2 devices on the left and right. One of these is going to be an infrared LED, and the other is going to be a phototransistor or photodiode that can receive incoming LED communications. Our third device is in the middle here, and that isn't an LED. No, that actually looks like it's probably just a cadmium sulfide photocell. Hang on a moment. It's definitely one of these, and these are on a ceramic package. So that's why we're seeing this comparatively dense blob in behind that, compared to the epoxy-coated LEDs and phototransistors, or photodiodes, which are entirely invisible at this level of attenuation. 2 questions, actually, that we're starting to get an answer on here. So we got our infrared transceiver and a light sensor. So there's definitely a microphone somewhere in these, because they can hear things being said, to the extent that the NSA temporarily banned Furbies from being brought onto any of their properties or offices, which is fun to think about. Let's see if we can find a microphone. There's these 2 contacts just kind of hovering here. Oh, you know what? There's no copper winding in there because there's no copper winding to have in it. It's an electret microphone. It behaves as a capacitor. There aren't heavy conductive elements in it. Yeah, okay, that would do it. We already found that ambient light sensor, and a couple other things jump out, more mechanical ones. We have a tactile switch right here. Now that's going to be in back here. Got it. I have no idea what that button does. We'll need to look that up later. Button in butt. Below that button, that is of undescribed function, these 2 wires down here. And those, I think, are also forming contacts for a button. But those are in the moving base. So those are going to be the reset switch. Other obvious sensor, and this one's kind of cool, is there's a tilt sensor. So this is a free-floating ball that is held in probably a cardboard tube or a phenolic tube between these 2 plates with holes in them. And when you invert this, and maybe we can hear this. Yeah, there it is. So you can hear that ball moving around. When that ball reaches the top of travel under the force of gravity, because you've flipped the whole thing upside down, it's going to make a contact between this fork on the top and this ring. And that's going to send some electrical signal into the computer on board. Now, this first one is going to take a lot of time because everything is new for us here, right? But I really can't wait to show you how this all evolves over time. I can't wait to see it myself. So stay tuned. This is going to get fun. Because I guarantee if we fast forward 26 years, this thing is going to have a full IMU inside of it and no moving parts in any of the electronics. So here on its right side, I found this little guy. And I have no clue what this is supposed to be. I can feel the hole in the frame. I keep thinking I'm done, but the longer I look, the more we're finding here. This is cool as hell. So I found another optical element, and I was looking at it going, what the hell's that for? And then I saw it here. So if you look real carefully, so on the main board, we have another LED package, and cut this thin. Yeah, you can actually see the package itself. So we have a little axial 3 or 5 millimeter LED here. I was going, what could that be for? It's not pointed outside the case. It's not going to help with anything. But it's not for you and I to see. What it's for is for this phototransistor to see. Because what that's going to be doing is detecting the position of the gear train that's inside of it. That's really cool. So that's how they're doing control of all the motors. And by all the motors, I mean the singular motor that's inside of this thing. So that's how they're getting the feedback into the motion system. It's literally just one phototransistor and one LED providing all the position feedback that we need. And then, you know, some dead reckoning and wild guesses later, you get exactly what you want. So when we were planning this episode, Daryl, our editor, told me, yeah, just, you know, keep it to 10 minutes of Furby. It'll be fine. We are still on Furby 1 and it has been 36 minutes of recording. Yep. That's a speaker. Pretty clear speaker structure. This whole thing is going to be the diaphragm. Our voice coil is wrapped around this permanent magnet, and then our electrical contacts are up here. Open, front. What makes this thing move? Now, part of the engineering brilliance of this that I probably would not have recognized a day ago is how little there is going on in here. We have a single motor driving all of the motions. Now, what are all of the motions here? I think that is the beak going for a chewing sort of motion and a talking motion, and also rocking the entire base forward and backward to give the impression of movement. So we got a single motor. What kind of motor is it? That is a permanent magnet brushed motor. BDC PM motor. And let's see if we can figure out what it's actually attaching to, because we can clearly see the shaft of the motor coming off right here. But we don't actually have a good enough view of what's going on to know what that's connected to. You know, this would be easier if we just went onto a cardinal plane. Oh, and the gear train begins. Okay, you guys gotta make sure to let me know down in the comments if I missed something, because I will definitely have missed something in here. Motor. Motor goes down, motor drives a gear. And that gear drives a gear. And that gear drives a gear on the same shaft. From this gear to this gear. That gear drives this gear. That gear drives this gear. That shaft that that final gear is on, it runs up a ways. And it enters what I'm pretty sure is a worm gear. So let's switch perspectives. Let's go along the y-axis instead and see if we can find where we left off here. There should be a big metal shaft running up and down opposite the motor. There. This is that same shaft we were talking about earlier. And it's going through a pivot in the subframe of this whole unit. It's attached to this drive gear, and it also has a worm gear right here. Now that worm gear is going to be engaging this gear on what I believe is going to be a box of cams that do all the motion inside of this thing. That's pretty clever design, and I think we're going to see that retained throughout the future variants. Now, we also have in here our happy little friend, the infrared LED. So we have our LED, and that is actually firing up towards this gear right here. Now that gear right there, it's gonna have a slot in it somewhere that interrupts the flow of light up to this phototransistor. That phototransistor right there, it's gonna be sending a signal to the microprocessor down here on the main board. And with that, it can keep track of how fast it's spinning the motor. When you know how fast you're spinning the motor, you can actually control how fast you're spinning the motor by adjusting how much power you're sending to it, even though the resistance it's seeing may change. And we're counting this on a relatively high-speed shaft. By relatively high speed, I mean, well, every time this shaft rotates, this wheel on the cam box will advance by, I think, 1 tooth. And this has already been reduced by what looked like a factor of about 20 to 1 from the motor, which is over here somewhere. So with this, we can get really fine-grained control of the motor speed. And it only costs like 5 cents in parts at scale. That's kind of friggin' brilliant. What else is on that shaft? Well, oh boy. We got some magic doohickeys here, I dare say. We have cams. Dude, there's so much going on in here. What? Starting from the right-hand side of the head, first of all, we have this real big cam. And what this is gonna do is it's gonna impinge on this post underneath it. And all that post is doing is it's pushing out this bottom plate. So every full revolution of that bull gear and that shaft, it's gonna cause this guy to rock upwards once, and just briefly, because for most of the rotation, it's not impinging on it. You hit that high spot and thump, thump. So it's gonna do that once every revolution. That's pretty cool. I think devilishly simple is what's gonna describe most of what we're gonna see. Next piece, and it is actually just a single piece of plastic, we have this big old cam follower. Remember, this and this are on a single piece of material. So this pin is gonna be riding in this groove as this rotates. So it's gonna be getting forced up and down with some sort of particular motion profile that you could read out as how far it's gonna have to be from the center point at any given point in its rotation, which is just how a cam profile works, but you gotta remember these things. Now, what is this pin here driving? That pin is part of this big arm. It's more complicated than I thought, I'm afraid. So, this big C-shaped arm goes up here, and it interacts with more parts up here. And we're gonna come back to those, because I wanna just figure out what the rest of this thing is. If we keep moving out, we have another cam follower, for it is always cam followers. And this one is gonna be moving in and out. What's it doing when it moves in and out? Well, of course, it's moving another massive arm. You see, it kind of looks like it's going right in towards this, which that should be the beak right there. The cam follower itself has these arms cast into it. And those arms are gonna behave like leaf springs. They also have those nubbins at the end. And those nubbins extend out of the plane that we're looking at and towards the right of the head, where they get captured by the injection moldings that actually form the beak itself. So that means that as the cam follower spins, it's gonna force these 2 points forward and backward against some spring force. And that means that it can't bite down hard enough to actually cause damage, but it is still gonna move the entire beak assembly closed and open again, in both directions too. So moving along from the beak actuator, we get to here. Yet another cam follower. It is a camshaft, I mean, I don't know what you expected. There's our pin, there's our groove. So where does this one go? Now this one appears to have a bit more linkage to it. This is what's responsible for driving the eyelids to close, because this guy can blink. Yeah, like that. And of course, the motion for these eyelids is going to take place not inside of the eye, but inside the bridge between the 2 eyes. That way it's not, well, interfering with the eyes, and it lets you move both eyes at once. Hopefully, there's nothing else on this cam follower, because I am starting to lose my mind, and I can't imagine that the engineers in 1998 were doing much better. So let's go back and sort out what that one going up to the top of the head is. So, the motion path on this cam follows up and away, and just kind of disappears. And that's because we need to look at it from, that's a perspective. We need to look at it along the other axis to see where this motion is actually going. Yeah, our cam follower ends in this plate here, and that plate right there becomes these 2 gear racks, and those 2 gears actually form the arms that the ears are connected to. This is kind of brilliant engineering. They're using one motor to get at least 4 motions. I probably missed one, and I'm pretty sure the eyes move, but I'm running out of time. It's 58 minutes. We are 58 minutes into this recording, and I am done 1 Furby. And I must tip my hat to the designers at Tiger Electronics in the 90s. This is beautiful. Beautifully constructed and engineered. And, well, I mean, hey, it shows. It still works 26 years later. I don't really want to put batteries in it. These things are really annoying. Now, look, guys, if I missed something, you need to let me know, because I'm not going back to check myself. And you can pull up the scans yourself on Luma Field Voyager with the link in the description below. This was the 1998 Era 1 Generation 1 Furby. So that brings us from our original 1998 model to the same generation, same era, 1999. Any obvious changes on the bottom? Uh-oh, yeah, no, they did change things. The floor plates aren't even the same, and they're different sizes. Oh no. I gonna have to do all this over again? Let's dig in. Okay, so is it the same or is it wildly different and I have to shoot this entire thing again? Now I'm gonna go ahead and say this is the exact same on the inside. And I'm also gonna say, thank goodness. So here we have our microphone, our cam switch, our motor, our optoelectronics assembly, front button, front speaker, reset button. There's one little change with the reset button. We'll get to that in a moment. Rear button. Mechanically, everything's the exact same. The only change I can spot, and there might still be some things, is that reset button has gone from being an open electrical contact that's being made with parts floating in the injection molded assembly. It's actually gone to being a tactile switch that is soldered directly onto the wires and then installed in the assembly. This is probably just a little less flaky than how they were doing it before. It won't reset under hard vibration or something like that. Anything else we can spot that's different and worth talking about here? I think it's the same, but I want to look at whether those cam paths look similar. As I understand, one of the ways they added variability to the different Furbies that were all, the same model otherwise, is that the cam profiles that are followed by the different moving parts are different. Also, they changed the voice, and that actually changes whenever you reset the Furby, but the cam profiles, they're locked in from the factory. So let's take a look. If we go over here to the one nearest to the microphone, we got that tooth, and then this profile. This is on the 1999. Let's look at the 1998 again. So they did change the actual part. The injection molding here is a little bit different, but I think I could pretty comfortably call that the exact same actual shape. Thank goodness. Let's move on. So our third one is this Gen 1 Witch's Cat. Now, this one is special. And the reason it's special is because there are no electronics in it whatsoever, and it is, in fact, full of beans. Just all beans. Just all beans. And all beans and a little piece of wire in the ears to give them some shape. The microphone, full of beans. Sensors, full of beans. Movement, full of beans. Electronics, full of beans. Speakers, full of beans. What the f***? Full of beans. Let's move on. So, this is our fourth model, or really third model. I don't think Captain Beans counts. And this is a 2005 Era 2 emotronic. Namely, it is the Grapesicle lad, who is looking extremely stoned. What delights and torments await? Let's dig in. Okay, it's not as bad as I feared. They didn't change everything. So let's go and look for the parts that we know are there. First things first, right here up front, we have an essentially unchanged belly switch up here. We have the same speaker as before, just rotated 180 degrees for what I'm sure is a very good reason. Now on this model, they've abandoned the singular foot and instead have actually two individually articulating feet. You can see this is going to get a little hectic because they actually have included a second motor. So here's our first motor, here's our second motor. Something else they've changed is that this guy doesn't have the hole in his head. So there's not actually going to be an infrared transmitter and detector in there. And sure enough, if we zoom in past the fur, I don't see any optoelectronics in the top of the head, which doesn't mean this is going to be any easier. Now another thing that thankfully they don't appear to have changed is I think our friend the mystery microphone is right there. It's a little tough to see, but that right there is our microphone. And it's the exact same model as before, so there is no change in the microphone. First thing that really jumps out at me in this model for sensors is that they've actually added this long looping wire that goes down basically the entire outside of the dude, on the backside too. And I think that's some form of sensor. That's going to be probably a capacitive contact sensor. So let's just make a note of that. Capacitive sense wire. The other sensor that jumps out at me as different is up here in the back of the head. We have a full-blown rotary encoder assembly. So this is actually the same mechanism you'd find inside of a high-end mouse wheel. We have an infrared transmitter and a pair of infrared receivers. And those are hooked up directly to this integrated circuit that's taking those signals and either directly buffering them and sending them down these four wires, or it's actually doing the counting on board and communicating digitally over these four wires and receiving power on the other two. So these are either going to be power ground and a AB quadrature signal, or power ground and I squared C, or something similar to that, communicating down those wires. This is a much higher end sensing solution than we saw on the Era 1 Furbies. Full-blown rotary encoder. Now the question is, there's two motors, do they need two of these full feedback systems? And I imagine the answer is going to be yes. Until we find that second rotary sensor, let's look at some more things that have stayed the same. We still have our inversion sensor here. And it's still the exact same. We've got a ball and 3 bent metal pieces. If it works, it works. Over here, we have a contact sensor. This one's built into the back. Those are about the same as they ever were. Back contact sensor, tilt switch. Is that a switch? Yeah, down here on the bottom, we have a design revision that probably would have been welcomed by every parent whose children owned one of these, which is a hardware off switch, which also has a try me mode. That's new, that's new, that's new. Of course, we have more cams, and these are using new cam profiles because they're installed in different spots. You have to change what the cams look like. Once again, we have up top that same structure for the ear actuator off of the one cam profile. We have another path here that's going to be moving the eyes, it looks like. For blinking, we still have the exact same design, and hey, again, if it ain't broke, don't fix it. And hey, sure enough, we even have the exact same beak sensor. Now, of course, this is also driven from a very similar gear train. The only real difference is that this motor doesn't directly go to the gear train. Instead, it goes through a belt drive. If you look at this carefully from this perspective, you can see the belt snaking its way between these 2 pulleys. And then once it gets to that top pulley, it goes into a gear train right here, and that gets us a reduction, and then into a worm gear, and then we're on the cam drive again. So in this top gear system, we have a rotary encoder directly reading the high-speed input gear. And then we're gonna still have to have some sort of homing or zeroing switch on the cam itself. Hello? Hello? Oh, there it is. There's your switch, there's your nubbin, there's your leaf spring. So yeah, we still have the reset switch and a rotary encoder. So that's basically the exact same as it was on the Era 1. It's just they've had to rejig some things, more or less. So let's take a look at the bottom gear set. Well, this is constructed the exact same way. So we have our motor here, this drives that drives that, of course, and somewhere down in here, we wind up in another cam profile. So once we're in that cam path, things get a little bit spicy. And by a little spicy, I mean they get mechanically very complicated. Before we start actually driving this main drive shaft, we need to have a torque limiting clutch, which I really was not expecting here. But this whole assembly, which we're actually gonna zoom in on because that is very, very cool. So this outer gear is driven by a gear coming in from the gear train, sure, whatever. But in order to actually drive torque into this central shaft, it needs to go through all these little detents that are on these leaf springs that are attached to that shaft. And those detents can only provide as much torque as it takes to bump this detent into the next spot on the inside of this gear. So if something jams up the feet, and that is what this gear train drives, the feet, if something binds up the feet, it's just gonna go click, 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 instead of, stripping gears, destroying itself, or injuring the user. Now this central shaft now comes on out, gets coupled to an eccentric shaft. Now the foot is attached to this Scotch yoke, which rides on that eccentric pin, and that'll just drive the foot up and down. In the middle of this, we have our cam timing switch. And you'll notice a difference here. This actually has 2 lobes on it. Why does it have 2 lobes? Well, this system repeats every 180 degrees, so you don't actually need to know where 0 degrees is. You just need to know where 0 or 180 is. So this will send a reset signal to the microprocessor every 180 degrees of output of that final shaft. Now I've got to say, overall, this ballooning of complexity between Era 1 and Era 2 leaves me a little concerned for how difficult it's going to be to figure out what's going on in Era 5. So stick around to the end so you can see that chaos come together, because I can't wait to dig in. So finally, let's take a look at the electronics in this guy. And curiously, they've moved them from being a horizontal plane to a vertical plane, and that was so that they could fit the batteries in vertically. I don't really know why they chose to do that, but it'll work. The electronics might be the exact same, actually. The board's pretty much the exact same. They've just ditched the communication. That's all for the Era 2 Grape Skull Furby. Let's move along. We're gonna jump ahead another 7 years to 2012. I think this is a return to basics. I think the Era 2 emotronics may have just been bigger and different just to be bigger and different. Because I think this is gonna be pretty much the exact same thing we've already seen on the inside. So let's take a look here. I was completely wrong. They've changed everything again. Yeah, we still have our, I believe, capacitive sensing wire up in the front. And we have ditched the contact button in the front because we're just doing that with the capacitive sense now. Now, that also means that we've moved the speaker somewhere else, because the speaker used to be right here in the front, but they've put it somewhere else now. And this is something I was expecting would happen, is that we'd see a move as time went on from large open diaphragm speakers to smaller board-mounted ones. First thing that stands out, speaker's been moved to the side. Sense coil is there where we already said it was. Very big spring. Does this still have the moving? Oh, okay, because this has a different form of motion now. It kind of scrunches the torso instead of moving the foot. Very curious to see how they're pulling that off. Also very curious to see how they've made that back drivable. We're back down to a single motor. That single motor is going to be driving some sort of cracked cam path that we can't see at this attenuation level and being monitored by this rotary encoder once again. Will they have kept the spring-loaded dry contacts? Yes, they have. Here is our index switch again for the cam path. Nothing wrong with that. Oh, no, you know what? That's different. They've changed up our ball tilt sensor. Look at this. So instead of just being a vertical tube where the ball could either fall to the top or to the bottom, we now have a whole slew of contacts here. And what these are arranged for is that you can actually detect gravity being in any cardinal direction. So the ball can fall onto here, it can fall onto those two contacts, these two, these two, these two, and these two. And those 6 get you, well, all 6 main positions: up, down, left, right, front, back. So that's actually a pretty significant difference there. 6-way tilt sensor. Now, one of the key differences that I'm seeing that sets this generation apart is the eyes have been mechanically simplified but made way more intricate, because now there's a full-blown LCD display behind the eyes. And they still have that shutter that drives the motion of the eyelids. So you have eyelids, but you also have a digital eye effect in here. They've also gone back to having the forehead chevron, but we're still missing the infrared communications. Okay, so let's take a quick sweep through what is undoubtedly another really cool cam path. We have our ear, eyelids, and beak, all controlled by this one cam motor. They've started getting optimistic with these cam paths. Look at that. We got like 1, 2, 3, 4, 5, 6 corners in this thing. That's way more than any of the previous models. Here is our rocker. So we have our cam arm here. It's a 9-shaped thing. And that's being driven by this peg that's engaged with this cam path. That's driving this bull gear. This pinion is reacting to that. That's going to be pushing on either side of this big old torsion spring. Now, pushing on either side of the spring like that means that if you moved your input side further away, it's going to apply a force in that direction to the output. If you move it closer, it's going to apply a force in that direction to the output. But you can still move the base against that spring without backdriving the motor. And we have to make sure not to backdrive that motor because, once again, we're back to using a worm gear. And you cannot backdrive a worm gear. It'll just break something. The other thing that we have in here that you can actually see clearly now is this code wheel for our rotary encoder. Every time one of the slots passes between those two elements, you'll see a pair of pulses in a particular order. Those pulses can be recorded to digitize the rotation of that wheel and keep track of its location, which is pretty cool. Of course, we still need to keep track of where the actual cam is, and for that, well, we still have a big old springy switch somewhere. And sure enough, we do still have those contacts riding off of this little bump, and it is a little bump, in this one wheel, and going over to this pair of contacts just beside the motor. So our next question here is the electronics. Now, the first thing that kind of springs up here is that everything seems a little bit more compact. And clearly we've gotten to a point where they can just throw a full-blown pixel LCD in there and not really care about the price impact. So we've got some differences here. And indeed, there is a greater level of integration going on. And the sort of form that that integration takes is that things like our microphone are still here and still look pretty much the same, but they're just smaller now. They've all been compacted down onto this, and there's very few discrete components now. Well, what I mean by discrete is if we look back at our Generation 1 unit, we kind of see this forest of components. We got things just kind of sticking up out of the board and then folded over out of the way. There's transistors just kind of plonked into the board, standing up. And I suspect we will find, if we look at this, first of all of those will be surface mount now. And secondly, we're not going to have as many of them, or at least they won't take up as much room. For instance, we have this little guy. That is a surface mount transistor package, and it's minuscule compared to those through-hole ones. Those through-hole ones would have been TO92 package. This is going to be a SOT23 package, which are about the same footprint, except a SOT23 is a millimeter tall, and a TO92 is about an inch tall. So huge differences. Even things that are almost unavoidably through-hole packages, like this crystal oscillator here, it's tiny. Like that's probably a 2mm package there. This thing's only 4mm wide, probably barely sticking up more than 4mm from the board. It's all just a lot cleaner and tighter together. Something that's freaking me out a bit here is I don't actually see a microprocessor. So maybe, got it, our microprocessor is hiding right there between the eyes. And that is actually a directly attached silicon die. Let me see if we can zoom in on that real quick here. There it is. All right, cool. Keep in mind we're looking at this sideways, but here is our microprocessor. Kind of a diamond shape, how we're looking at it now. That right there is our microprocessor. And you'll notice it has no leads, no solder joints. Because what that is it's the silicon die straight from the fab, glued directly onto the circuit board, and then wire bonded into place and covered over in a piece of epoxy. If we have high enough resolution, we should be able to see the individual gold bond wires holding it onto the board. There you go. You can see the footprint that it's been wire bonded down to. All these contacts right in here. So this is an incredibly cost-effective way to assemble millions of pieces of electronics. If you have the volumes to manufacture your own custom piece of silicon to do exactly what you want, and you know that the only board it's ever getting assembled on is in your factory, well, why pay somebody to put it in a piece of epoxy packaging with a lead frame, do all the wire bonding, and then solder it? No, just send the wire bonding guy your boards and have them bond it directly to the board, cover it in a piece of snot, and you're good. You're done. Brilliantly cost effective, and you'll find it in all sorts of high-end and ultra-low-end electronics. We took a look at a pair of high-end calipers, video coming soon, turns out they're very difficult to explain. They use the same packaging technique because they're making the exact same device a million times over. And it's the exact same thing these guys can do because they're making the exact same device a million times over, just at a wildly different price point. So that's your main microprocessor right there. Let's bookmark this so that you guys can actually find this when you follow along with the link in the description. Now this does still leave me wondering, is there any form of intercommunication on these guys? Because I thought that was kind of their whole shtick, was that they'd, chat with one another. That kind of looks like a piezoelectric transducer, and that would let it produce ultrasonic chirps and receive them. Got it. The Era 3 Furbies use ultrasound to communicate, and I think that is what we're looking at right here.
To the extent that the NSA temporarily banned Furbies from being brought onto any of their properties or offices.
And it's just sitting opposite the microphone. Now the microphone won't work in the ultrasonic range, so I think they're pulling double duty on this transducer for transmit and receive. And that's all been built into the same circuit board in the front as the eyes and everything else seems to have been. In fact, the only spots where there isn't a circuit board there is where the cams that are actuating the beak need to reach through. So next up, let's take a look at its nearest neighbor, the Era 3 Gen 3. Now, this one, 2012, this one, 2013. There's no clear difference from the outside. They have the same battery cover, the same eyes, although this faceplate, a little bit different on the newer model. So let's dig in and see what we find. Spot the difference, spot the difference, spot the difference. I don't see anything. Okay, one tiny difference here is they have changed how our little ball switch is oriented. They've changed what circuit board it's mounted to and which direction it's facing inside of the system. Now that doesn't really change its function, just how you have to wire it. Now this next one is weird. It's the same generation as these two guys, but it's a little different. This is the Party Rocker series, which this is kind of a little accessory guided use. As I understand it, can communicate over ultrasonic with the, the mothership here, and also with a phone app. It's a lot smaller, a lot simpler, and a lot more dorky looking. Now something they've done with the eyes here that's kind of cool, and we probably won't be able to pick up on the CT scan, is they actually have lenticular lenses in front of them. So as you tilt it up and down, you get different looks on the eyes. So what do we have going on here? We have loudspeaker, microphone, ultrasonic transducer. Oh, look at that. We have an adorable little tilt switch. It does really feel like this should have some actuator, way to force motion, but it just doesn't. Okay, yeah, nothing more to observe here. That's a shame. Simplified tilt sensor. So let's keep moving along here. Our next one is the 2016 Era 4, which is this guy. Now this has a couple of mechanical features that do immediately stand out. Doohickey on the top, which can be pressed in as a button, and the forehead thing where the infrared sensor used to be, it goes way, way in as a button. The ears are very different in their dynamics now. These are like free swaying, which strictly, like in the original, they're kind of free to move, but they're not flying around. There's a lot of external differences, but let's find out what's different under the hood. Well, we still have the sense wire down below, and it looks like mechanically we have more or less the same sort of things going on as we had in the 2013 and 2012 generation. I suspect that everything's going to be pretty much the same way that it's been for 12 years, so let's dig into the particularly enticing parts. Like what's going on with this button in the forehead. So curiously, inside the forehead hole, we have 8 electrical contacts. I would not have thought to look for these without the CT scan, but no, sure enough, if we press the thing back, there are electrical contacts in there. There's nothing actually in here that detects whether that button is pushed in or not. The other thing that stands out as different, just superficially, is it's got this doohickey. Spring-loaded, feels a bit like an arcade joystick, almost. Now that's situated directly over top of a surprisingly intricate circuit board. Okay, let's take a closer look at this forehead stick. Oh, you know what? That's constructed a lot like a D-pad off of a game controller. Oh, it totally is. Sure enough, as we scan through this, we have 4 silicone domes, and then we have 4 contact pairs on the circuit board. Then, in the center, we have this guy, and this is, of course, an RGB LED. And that LED is there to make this whole stock light up. 4-way D-pad stick. We got our forehead hole. Moving along, on the sound side of things, we once again have loudspeaker in the left-hand side of the head, a microphone on the main circuit board, and the circuit board is in the front again, and we have one mystery. I actually can't tell what that thing is. It looks like it might be the sensor for actuating the tongue. Kind of looks like a magnet, actually. Now, rare earth magnets tend to be very, very dense on scans, and that's because, well, they're made out of heavy metals, and heavy metals block a lot of X-rays. So it would actually make a lot of sense if what we were seeing here was a magnet, and some sort of coil, perhaps. Because copper also shows up pretty densely, though not quite as densely as neodymium does. So I think the bottom lip of the beak is spring-loaded, but it's not quite spring-loaded in the same way as the top beak. This is a very stiff, and it's got a twang to it. You can hear the spring in there. This bottom one, very lightly spring-loaded. Yeah, that could be a magnet. Something I'm really curious to see is, have they finally ditched that electromechanical assembly for the tilt sensor? Because it looks like the answer is yes. Yeah, I don't see an errant steel ball anywhere in here. Era 4, we have finally ditched the electromechanical steel ball in a cage tilt sensor. And the reason for that is going to be that somewhere in this whole package, there's going to be a MEMS accelerometer that can do all of that work for much lower cost than several custom bent steel components. But where? So here we have our 2016 electronics. Let's see if we can find us a MEMS accelerometer on here somewhere. But I'm expecting something like a QFN package. Now, I'm not saying it is, but this device right here on the board behind the eyes could very well be the replacement for that whole ball in a cage assembly. Just a single surface mount component doing the work of 5 custom-made metal pieces. This is the beauty of tightly integrated electronics. Now, they also have a lot of other stuff on this circuit board. We still have a wire-bonded custom IC in the middle here. Fairly large integrated circuit hiding under an epoxy bulb. We're nowhere near the resolution to pick out the bond wires, but you can see this sort of radial structure where all the wires are supposed to go that connects all of these, and there are a lot of them, contacts on the PCB onto the die that sits right there. They're still doing this. They still have enough volume that they can make their own integrated circuits and mount them to the board without paying for packaging. Meanwhile, elsewhere on the board, we have some massive packaged ICs. Look at the size of this lad. I have no idea what that does. Now, another thing that becomes clear here is that they've actually split the display into 2 LCDs, each one dedicated to its own eye. And you kind of see how there's this mechanical split down the center line of the entire assembly before we actually encounter our 2 LCDs, which aren't, curiously, mounted in plane with the circuit board anymore. So I think what's likely happening here is that this chip in the middle isn't actually a Furby integrated circuit. It's a dual LCD display driver, because you're going to be making a heck of a lot more of those than you are Furbies. Everything else on here is the actual application-specific stuff. And then, on the backside, we find another fun little detail. here we have the first thing that I'm going to start calling a very modern device. This large rectangle, it's similar to an ESP32. This is an integrated radio module and microprocessor. And that's your die, and somewhere down the stack, we have a Bluetooth antenna. This is the exact same way you'd find an ESP32 or something similar to it being built. The question is this what's doing all of the processing, or is this just the radio? And there's not really a good way of knowing that, considering how much other silicon they have on here. So is the application-specific stuff on this little sub-package, or is it built into the rest of the board? Well, I guess the only way to actually answer that would be to have designed it, or to reverse engineer the full board. But instead, we can just reverse engineer some small little details, such as the buttons on the head here. Okay, so we can see from this perspective pretty cleanly. Little interface board for those buttons up here. And we have some wires coming off of it going over to this connector, which is actually on this daughter board on the right-hand side of the Furby, and some other wires going on it that go into this main board right beside where that radio board. Yeah, it's on this connector right next to there. So let's take a look, see where those buttons go. My inclination is to say this is just a power supply. Okay, so these 5 pins, this one definitely goes directly into that coprocessor. And that's really got me thinking that this whole thing might just be an ESP32. This is DRAM, that's temporary storage for software that's underway. This is probably flash. This is actually the processor. This is actually just the Bluetooth chip. Power supply is over here. The displays may be smarter than I thought and actually have onboard controllers. So that would explain pretty much how everything on here is working. We're still gonna need some form of synchronizer on this, some index pulse that happens once per revolution of that camshaft. In a design now in 2025, we have very inexpensive chips that can take the end of a shaft like this with a magnet on it and immediately get an angle out of that just by being in plane with it. And we even have a circuit board where it would make a lot of sense to put that. These chips were available in 2016, but they have only ever come down in price. I don't know whether those would have been cost effective at that time. But as it stands, I don't see any way they're getting a signal out of this. I feel like with every era, these profiles are just getting funkier and funkier. Yeah, so our first cam follower here is going up there, forms a rack gear, and that's gonna drive the ears. We can see that we have this same mechanism left and right for each ear. How are those actually putting torque into the ears? Via a torsion spring, which makes an awful lot of sense because that gives us a lot of flop, but we'll still be able to induce torque in that according to the camshaft profile. That's good. Our second cam follower is this guy. What's that guy doing? Well, it's going through some sort of spring into this drive pin, and that seems to be the collective thrust on the foot plate to give an up-down motion. Well, I'm not too sure, but it's definitely impinging on that floor plate. Yeah, it should be lifting up and dropping back down the whole body. Okay, still seems to be a large voice coil speaker. Yep. They seem to have almost entirely abandoned mechanical switches in this design. Instead, we have these contact wires just terminated in blobs running just about everywhere. Hey, if it's cheap and it works, we still have a little micro switch for our reset button. But now, unlike in the 2012 model, this is soldered to a tiny little circuit board instead of having wires going straight to the individual legs. It also has 3 wires. I don't know why it has 3 wires. Now what? I don't know what you're supposed to do with these, I'll admit. First things first, what does pressing this do?
Would I wait your car wait? You fight. Whoa! Strawberry is jelly.
Why are some of the words English?
I love that.
That's freaking me out a bit. Other thing of note here is that the left and the right legs actuate differently, which does give a body sort of roll to it. Can I bounce this on something? If we do that. From where I'm holding it, I can feel the left and the right side, the 2 different legs kind of shifting down individually. That is, in fact, a lit up stock, and this should have multiple directions of travel. They should have left it as indecipherable gibberish. Mildly cursed. Now, so what's fun is that even at full extension, under the cam path, you can still backdrive these. The full color LCDs are really, really well done on this. And where we were was wondering what this button does when pressed. And the answer is, true to what I was seeing, there doesn't appear to be any reaction to that button actually being pressed. All the reactions are from having to actually handle this thing in order to press that button. But if you just have it, sat on a water bottle, that does nothing. I've learned what that port is actually for. So apparently this guy comes with a sleep mask fresh out of the box. And that sleep mask inserts into this port, covers the eyes. When that sleep mask bridges those contacts, it tells the controller on board, hey, the sleep mask is installed, it's bedtime, you can be quiet now, you can stop making noise, stop making light, stop moving around. And I think that that is a great design idea to add. Anyways, back to the video. The electronics are incredibly well integrated and fairly modern. There's a single motor, it's driving 2 ears, 2 feet, and it has one unknown use cam that I just can't quite wrap my head around. I still have no clue, absolutely no clue, how it's detecting the index on that cam rotor. Bluetooth connectivity, has the exact same microphone and exact same speaker as before. And one last thing I noticed is that actually this tail is firing a tactile switch. So I got something wrong. Yeah, this push button, which I was pretty sure was the reset switch, it's actually gonna be the tail switch. But the actual click action from the tail is happening through this bespoke component that's sliding over this contact on the same circuit board as the reset switch. So earlier when I was pondering, why are there 3 wires going into the reset button? Well, it's because there's actually 2 buttons there. So you'll have a common contact, probably ground, and then a signal contact for reset and a signal contact for the tail pull. And in case you were wondering, pulling the tail makes it fart. I don't know why that's the one feature you'd make sure to implement with your new sensor. Now it's time to look at how this has all come together after 25 years of research, development, and innovation. We have, right here, the Era 5 2024 Furby. And my initial impression is I think they cheaped out. First thing that's jumping out at me is there's not much going on in here. Like if we look at this from the side, right, and we peel away all the plastic, and then compare that even to the Generation 4, there's so much less going on in the Era 5. Where'd all the things go? First things first, let's run through and see what sensors we can find. And that's easier said than done, because as far as I can tell, we have a button and a button, another electret microphone, and that's it. No, seriously, like I think the only inputs on here are the tongue, the button in the forehead, and the microphone. I'm actually disappointed. I was shooting this entire video with the premise that we'd get to the Era 5 Furby and just be blown away by the intricacy and the brilliance behind it, but no, they cheaped out. The 2016 model is way cooler on the inside than the 2024 model. Let's pick this guy apart and see exactly where things have gone wrong. There's a lot less going on behind these eyes just looking at it. It doesn't seem to have any moving parts for the feet. No, that's not true. These feet can move, these ears can move, and that's it. Nothing on the face can move except for the combination eyelids and eyes. What the heck, Hasbro? Come on, it's the 21st century now. We should have all the intricacy that we had before, but better. Not just make the same product, but cheaper and with fewer features. We have the same direct drive immediately off the motor shaft onto our gear train. We have our synchronizer wheel again. We have our encoder code wheel here, and that's working in conjunction with this circuit board, which has dual slot phototransistor right there. Now, one thing I will say they've done differently here is that the injection molded parts for these cams look the funkiest they ever have. So our first cam application is going to be the right ear, and that's following this path, but we actually need to slip back a little bit further here before we see how it's driving it. So the pin is at the bottom dead center here, and as we slip back, we have our actual follower, which rides around the shaft and drives the ear through this long, springy piece of plastic. That's long and springy so that, well, it has more spring to it and can accept more backdriving and back force without breaking or binding up the rest of the mechanism. We have some degree of electronics in the base of the ear here, which is probably an RGB LED that lights up the ear. And let's just switch perspectives so we can see the gear train that actually moves the ear. Our cam follower turns into this gear rack right here, and then that connects to this pinion. Now, on the Era 4, we had a spring mechanism that limited the amount of force and allowed a whole bunch of travel through this mechanism. Here, that pinion just becomes the ear. Now, what this means is that all of this springiness is coming from compressing this piece of plastic. I don't love that. I kind of wish that was a real spring. But hey, if it works, I suppose. On the other side of the On the other side of the creature, we have the exact same mechanism repeated for the other ear. In between those two structures, I'm expecting to find something that drives the 2 feet. This structure, which is suspiciously oriented directly towards where the feet are in the front. Now once again, we have one of these living springs actually injection molded into the part. This is more of a heart-shaped thing than the spring-shaped thing, but it gets the job done. And that's moving the force down into this linkage. That linkage is going to connect to the foot one way or another. It's kind of difficult to make out, but we can see how this connection is finally being made to the foot. The foot is pivoting around this axle right here. And then it has a little nubbin that's attached to that same piece of plastic. That's actually where we're applying force to it. That is connected to this yoke. And that yoke is covering quite a bit of distance and moving at a bit of a strange angle in order to connect up via this pin here to that arm that was actually following the cam. So here we can see where the far end of that yoke is connecting to. So that's going to move in and out along this axis, and in doing so, it's going to move the foot about its axle right here, which will just turn into, you know, up-down foot waggling motion. Finally, there's one last motion taking place on this cam, and that is the eyes. And here we can kind of see the general shape of the eye, and I don't like this. So here we have the printed eye, and here we have the eyelid, and here we can just barely make out the eyelashes, which are in fact sandwiched between the eye and the eyelid, forming a 3-piece assembly, which I'll admit, if I hadn't seen what they'd done in previous generations, I'd think this was fantastic. But I have seen what they've done in previous generations, and this kind of sucks by comparison. This entire subassembly is pivoting around an axle right here. On that axle, there's also a torsion spring, which is actually linking it to this arm right here. That arm is impinged on by this crank that is at the end of the cam follower that is riding in this track. And with that, well, the one axis of motion that it needs to take care of is dealt with. That can move the eyeball down and up again. And the reason I can backdrive this from here is because it's going through that spring, which decouples the input from the output and means we can just build up force and kind of force it into the position we want without actually moving any of the mechanism inside. Now once again, I'm left with the question, is there some sort of reset mechanism on this so it can pick up where the index is? And I still just don't see it. Wait, I see it. I see it. It's like recognizing an old friend on the street. 2 dry contacts just hanging out on the back of the camshaft where it'll get hit by this nubbin. And that's the exact same design that we had, you remember it, all the way back in 1998, where they were doing the same thing for the same reason. Here it is in 1998, and here it is in 2024. It's kind of beautiful that that's the one thing that has persisted almost entirely unchanged. So the final question is, what's going on with the electronics in here? And they've made it much more compact, which is, you know, pretty easy to do when you remove half the features. It looks just a little bit simpler than the 2016 version. As far as I can tell, this does nothing that the 1998 version didn't do. And there's several things the 1998 version did that this doesn't do. But there's no radio communications taking place on here. There's no ultrasonic transceiver. Now, despite them moving the speaker behind this plastic snap-in grill, I think it's still essentially the exact same piece of gear that was built into all the previous models. So this big metal contact on the head is crimped onto this spring. And that spring goes from being a compression spring to a torsion spring, which is wrapped around a screw head. And finally, the end of the spring is soldered to a capacitive sense wire. So that gives you a touch sensor in the top of the head. Bewilderingly, appears to be the only capacitive touch line in the entire frame. This thing is severely pared back compared to previous generations. I feel there has to at least be a radio antenna inside of this thing. Supposedly, Furbies of this era can communicate with one another. So, is there a radio in here? I don't see one. Usually, the way to spot an antenna in a circuit board like this is to look for what shows up on the CT scan as a void space in the circuit board. And that's because you can't have copper underlay inside of the board in a spot where you're trying to put an antenna. But I just kind of don't see it here, man. So I'm gonna have to guess that the communication is just happening over audible audio. So overall, what does this thing do when you power it on? Well, I don't know what happens if we do this. Let's find out. Hey, Furby.
Oh, let me hear you. Now we fetched
That was the fear, yes.
Let's play. Press Heart Gem and say, Hey Furby.
Hey, Furby.
Now say,
Dance
Dance Party.
party.
Hey Furby.
The air horn. Oh my god, the air horn. Before succumbing to thoughts of violence against either it or myself, I do want to call some attention to how brilliant the design of the cam system is in here. With 2 sensors and a single motor, they have synchronized motion across 5 axes, and it looks organic. Like, if you didn't know how it was working, you could definitely fool yourself into thinking that all of these parts, which are all individually back drivable, are doing their own thing. Yeah, I'm still really impressed. Despite the cheaping out that's happened here, I'm very impressed with how much control they get out of all 3 of those independent axes, just with very carefully designed cam paths going into each of their motions. So by driving that motor forward and backward, you can choose to singularly move either foot, as far as I can tell, in like a waggling motion, the ears or the eyes. Like, it's pretty good, man.
Oh, nice words, Luna.
I can see why the NSA banned these.
You talking to Furby?
No, that's all there is here. I think Era 4 might be peak Furby, unless Hasbro comes out with something really cool in about 5 years. The full color eyes are kind of beautiful. The engineering behind all the actuators is just as clever as in any of these, and it's got Bluetooth, so someone's probably gonna hack it to run Doom at some point. That said, I really want to hate these for how frustrating they must have been, and must still be for any parents whose children have one. But there's so much cleverness packed into every single one of these guys. And yeah, I have a lot of respect for it. These things are really cleverly designed, and I hope you enjoyed following along. We'll see how long this gets edited down to, but I think it's going to be one of our longest videos yet. So hopefully you guys actually have found something in here that you can sink your teeth into and enjoy. It has been a pleasure sharing this with you. And if you want to check out the scans yourself, check out the link to Lumafield Voyager down below in the description and dig through. See if there's something cool you can find and see if you can figure out how the heck they're tracking the cam resets in the Era 4. Thanks so much, guys. See you next time. If you enjoyed this video, make sure to leave us a like. And if you want to see inside of something, leave a comment with your suggestion. If you want to support the channel, share this video with a friend or check out hacksmith.store. And if you want to see inside of everything, get subscribed.